In this video, we're going to solve a trig equation by first proving an identity. So it says, show that sec squared theta minus 1 over sec squared theta is equal to sine squared theta. And then it says, hence find the exact solutions of sec squared theta minus 1 divided by sec squared theta is equal to 3/4 for theta being between 0 and 2 pi. So we're solving this for radians. First of all, let's just look what we've got to show. So we've got to show that sec squared theta minus 1 over sec squared theta is equal to sine squared theta. So, starting with the left-hand side, we note that we've got sec squared theta minus 1 over sec squared. Now, that sec theta is 1 divided by cos. So we're going to replace this by 1 divided by cos squared. We're going to take away 1, and then we're going to replace the denominator by 1 divided by cos squared. Right, putting this over the numerator here over a common denominator of cos squared, that's going to give me 1 minus cos squared theta over cos squared theta. So we multiply that 1 by cos squared, and then that will then be over cos squared theta. And then if we have to divide by a fraction, if we remember our rules of fraction, we multiply by the reciprocal of this. So times cos squared divided by 1. Right, we notice here now that cos squared and cos squared will cancel out. And then we know that sine squared theta plus cos squared theta is equivalent to 1. Therefore, sine squared theta is 1 minus cos squared theta. So this now becomes sine squared theta, which is what we actually had to show. So that's now equal to the right-hand side. Right, we now have to solve this equation. So we now need to solve sec squared theta minus 1 over sec squared theta is equal to 3/4. So the first step is to replace the left-hand side with sine squared theta, because we've just shown that in the previous part, is equal to 3/4. Now that's a much easier trig equation to solve. To solve it, we need to take the square root of both sides. So the square root of sine squared theta is going to be sine theta. The square root of 3 we can't take, so we'll just leave it as root 3. And the square root of 4 is 2. However, when we take the square root, we need to consider plus and minus. Right, now do sine to the minus 1 of root 3 over 2. Remember, in radians, that's 60 degrees, so that will be pi divided by 3. Now do our South Asian tennis club, or cast, whichever way you remember it. Because we're looking in both, where it's plus or minus, we need to draw our angle against the x-axis in every quadrant. So that's pi by 3, that's pi by 3, and that's pi by 3, and that's pi by 3. And then we can work out our angles. So theta will be pi by 3. Remember, we're solving between 0 and 2 pi. So theta will be pi by 3. And then the next angle will be pi minus pi by 3. So that gives me that angle there, that one. So pi minus pi by 3. Then the following one will give me pi plus pi by 3. And the final one will be 2 pi minus pi by 3. Right, so working each of those out, that's going to give me pi by 3. This will be 3 pi minus pi, that will give me over 3, which will give me 2 pi by 3. The next one will be 3 pi plus pi, that's 4 pi divided by 3. And the final one will be 6 pi minus 1 pi over 3. So it's 5 pi divided by 3. So here are my 4 solutions. So this has been a video to show you how to solve prove an identity and then use that identity to solve a more complicated trig equation. I hope you've understood, and I thank you very much for watching.